Okay. Last week we couldn't finish with the topics that we were supposed to treat last week. So I gave you some practical questions for you to practice on. I hope you're able to do something on it.
Yes, sir. Yes, sir.
Yes, sir.
So who is having any difficulties trying to solve the practical questions? Do you still want us to go through them?
Sir, please, you can brush through.
Yes. Good morning, sir.
Good
Good
morning.
morning, sir.
Yes, please. I would like you to go through again.
Okay.
Thank you.
So we have the first question gave us some 2 points. The first point is 1 and 3. Then the second coordinates are also 3, -2. And the question is demanding you to provide the straight line, the equation of the straight line. So the first step is for you to get the slope. So for you to find the slope, so let's assume the slope is m. M is equal to what? Y2 minus Y1 over X2 minus X1. So that's the slope. So you need, with these points, 1 is X1. Then this 3 is x2. Then 3 with the first coordinate is y1, and the negative 2 is what? The y2. So let's substitute them. So it becomes negative 2 minus 3 over 3 minus
Negative 2.
negative
1.
2. 3 minus what?
Say minus 1 rather.
Yeah, 3 minus 1.
Hello, sir.
Yeah,
Hello, sir. Please,
yeah, I'm listening.
the first coordinate, is it 1 and negative 3 or 1 and 3?
It's 1 and 3.
Okay.
Yeah, who is disturbing us? So, and this will give us what? Minus 2 minus 3 is what?
Minus 5.
Minus 5
Minus 5.
over 2, right?
Over 2.
And we know the equation of the straight line. The simplest equation can be y is equal to m x plus c. It's the same as the one that I gave you. But the first equation that I gave you, I included the slope in the equation. I included the slope in the equation. But here's the case that if you are done with the slope, then you can substitute it into this equation to get the straight line. So y is equal to mx plus c. And we've gotten the m to be negative 5 minus 2. Then y is so you can, with this step, so let's move to the step 2. This is the step 1. Finding the m is the step 1. And we need to substitute it into the equation line. So y is equal to m, which is the negative 5, over 2x plus c. Hope it's clear.
Yes, sir.
Yes, sir.
Could you
So,
please go over that again?
okay. From the previous equation that I gave you, when you simplify
Sir,
it, yeah,
sir, sir, please, the negative 5 over 2. Can you make it a decimal form?
when you are done, you can make it a decimal form, but I just want to, make it step by step so that you all get the understanding. I hope I'm clear.
Yes, please.
So I'm saying that you first of all need to find the slope. That's the m. So which is y2 minus y1 over x2 minus x1. So substituting the coordinate into the slope equation gives us -2 over 2, -5 over 2. So now we've gotten the slope, which is the m. We want to substitute the m into the equation line, the straight line, the straight line equation. Therefore, y is equal to -5 over 2x plus c. So assuming we use the first coordinate, that is 1 and 3. And we are substituting the 1 and 3 into the equation. It becomes 3 is equal to -5.
Some people like you are so
So it becomes 3 is equal to -5 over 2 times the x coordinate plus c. I hope it's clear. So we are substituting the first coordinate into this. Therefore, simplifying it, it becomes what? Simplify it. 3 is equal to -5 over 2 becomes what?
those are we group like terms. We take the c, we move -5 over 2. No, first of all, we have to break the bracket. So -5 over 2 times 1 will give us -5 over 2.
Okay.
So now we take -5 over 2 to go and join +3 at the left-hand side. So that we'll get c standing. So that will be plus 5 over 2. Now 3 plus 5 over 2 is equal to c.
So please, I have a question.
Yeah. Go ahead.
Okay, sir. Okay, sir. I was thinking, since we have a fraction there that's -5 over 2, and we have a whole number that is 3, and from my primary school math that I know that any whole number is actually that number over 1. So I can consider that 3 can also be written that 3 over 1. Then
Yes,
if that's three
we will
three over
come there.
one, then
Uh-huh.
okay, sir. Okay, sir. Thank you, sir. Okay, sir.
So as a whole number, 3 becomes 3 over 1, then plus
Equals
5 over 2, right?
Yes,
yes,
sir.
please.
Is equal to C.
See.
Yes.
Then the denominator will multiply that 3
So
like a
that
cross
that will be 5.5.
multiplication.
5.5 straight.
Let's do it as what's the name?
Okay. As lay people.
As Ken said. So we are moving from our basic knowledge in what? Fraction. So simplify it. 3 over 1 plus 2 over 5 gives us what?
So sir, we look for the LCM,
Uh-huh.
and when we complete, we get 6 plus 5 over 2.
We get, so
6,
now we know that we have C is equal to 6 plus
5 over 2
6 plus 5
over 2.
like this.
Yes, sir. And so we add 6 plus 5 will be 11. 11 over 2. So C
C is equal to 11
over
over
2,
2.
which is 5.5.
Which is 5.5.
Yeah.
Okay. Let's see. Hope it's clear. Now we've gotten C. We've gotten C. We've gotten M. So we don't know the coordinate for Y and X. Therefore, the final answer becomes substituting the M and the C. It gives us Y is equal to minus 5 over 2 X plus 11 over 2. So this is the answer. Better still, you can convert it into decimals. It's accepted. Hope it's clear.
Sir, please,
Yes,
I have
sir.
a question.
Uh-huh. So
Um,
the final answer is Y is equal to minus 5 over 2X plus 11 over 2. Uh-huh. Go ahead.
sir, sir, does it mean that we always use the first numbers, like the first
Yes.
bracket?
Yes. Don't confuse us. Just use the first numbers.
Okay, sir, thank you.
You're welcome.
Sir, hello, sir.
Go ahead.
Sir, please, so if you have the graph and you want to get the intercept, I know 11 over 2,
Just make it
but sir,
decimal.
on the graph,
Make it decimal.
okay.
Yes. I just want you
Okay,
to understand,
thank you.
to appreciate how it's being calculated.
Okay, sir. Noted.
So what are the coordinates for the second points? The second question.
So the coordinates are 3 and -2.
No. We are talking about the second question. The question 2. We have the points of 7 and 4. Oh, you're
7 and
okay.
4. Yes,
Can I
7
stop
and 4.
here then? We move on to the new topics. Oh, hope you're okay.
So we can do this. Let's do this.
Okay.
And then 10 and -2. I don't know if you got it correct. No, it says 10 and 2.
And we know that the equation of the line is y is equal to mx plus c. So we've gotten this coordinate. Therefore, we need to find m. So m gives us y2 minus y1 all over x2 minus x1. So you want to substitute to get the m. So m is equal to, the y2 is 2. So 2 minus what? 4 over 10 minus 7. Then our final answer is what?
2/3.
-2/3.
Negative 2/3. So that's the m. So now you substitute this negative 2/3 into the x, into the y equation, the equation of the line. Assuming we are using the first coordinate, that's the 7 and 4. You are substituting this coordinate into this equation. Therefore, y
is 4.
y is 4 is equal to
Minus 2/3.
minus 2/3.
2/3.
Into
Then x is
brackets
what?
7.
4.
7.
7. Yeah.
7. Yes.
That's C.
So 4 is equal to
14.
minus 14 over 3
Plus C.
plus 2. Therefore, C is equal to what?
C is equal to, yeah,
4/1.
X plus C. C is there. C is 12/3.
Is that clear? Okay. So C is 4 as a whole number. So it is this. plus 14 over 3.
Yeah.
So the C will give us 4 as a whole number plus 14 over 3. It's the same as what? 12 over 3.
Plus 4 over 1.
No. If you want to, you are adding fraction. I hope you know how to add fractions at the basic level.
Yes, sir.
So how do
Sir,
you
Yes,
add
sir.
fractions?
you find the LCM first.
Sir,
Yes, you find the LCM first. So the
yeah,
LCM,
you find the LCM.
hey, Richmond, you are
The
disturbing us.
LCM is 6. The LCM is 6.
No, it's 3. It's 3.
So it's 2 and 3. Yeah, yes, sir. Yes, sir. It's 1. 4 over 1. Okay. Great.
So 1 into 3 is what?
3.
Listen, we are adding a whole number to a fraction. And every whole number is over 1. So before you can add, two fractions, you need to get their LCM. So LCM for 1 and 3 is 3. LCM for 1 and 3 is 3. So 1 into 3 is 3. So 3 multiplied by 4 gives us 12. So 12 over 3 plus 3 into itself is 1. So 1 multiplied by 14 is 14 over 3. Hope it's clear.
Yes, sir.
Then C is equal to
26 over 3.
26 over 3. So if you are substituting the C and M into the equation, we get y is equal to minus 2 over 3 x plus 26 over 3. Better still, you can make it a decimal number. Because in economics, you don't use fraction. You can just make it a decimal. Any question?
Hello, sir.
Yeah, Samuel.
Yes, sir. Please, sorry, I want this clarification. You see, we did this y minus y1 equals to x. That formula, can we use that same for this one,
Yes.
or we have
Yes.
a
It's the
okay.
same thing. But that formula, when you summarize it, this is what we get.
Oh, okay, okay.
Any question? I hope you can do the remaining coordinates.
Yes, sir.
Okay. Our next topic is the solution of equations in one variable, using one variable. Linear equations in the variable x is given that it's an equation that can be written in the form mx plus c is equal to 0, where m and c are constant, and whilst m is not equal to 0. A linear equation is also called a first degree equation or an equation of degree 1. You are saying that when you talk of linear equation, you are talking about an equation which is equal to 0. But in such equation, the m and the c are constant, but the m is either equals to or the mod or less than 0. So any number which is negative can give you 0. Any number which is negative is what? Less than 0. So let's try some example. So in solving such equation, you begin by getting the terms involving x on the one side and the constant on the other side. That is, when you have an equation which is equal to 0, you separate the like terms, like moving the variable with x on the one side and the other variable on the other side. So assuming we have mx plus c is equal to 0. So to solve this equation, you need to rearrange the variables. That is, making the one with x on one side, then the other on the left side. Therefore, you divide the m by the c to get the x. Okay, so example is this equation. I'm coming. So let's go to the drawing board. Assuming we've gotten an equation like x is multiplying, 3 is multiplying x plus 5 into bracket plus 2x is equal to 0. They've given you an equation like this, and they want you to solve for x. So in this equation, we are saying that you need to group the like terms on the one side and the unlike terms on the other side. So first of all, you need to remove the bracket by multiplying 3 by the bracket. That is, it gives us 3x can you see the board?
Yes, sir.
Yes, sir. Very clear.
Okay. So it becomes 3x plus 15 plus 2x is equal to 0. Therefore, you need to group the like terms. Grouping the like terms, 3x plus 2x, they are all like terms, is equal to. Then you need to move the 15. When 50 plus 15 crosses the equal sign, it becomes minus 15. Therefore, 3x plus 2x is what? 5x is equal to 15. Since we are finding for x, therefore x is equal to
15.
minus, yeah.
3.
So the final answer is what?
Minus
Minus what?
minus 3.
Yes. So these are some of the questions that will be coming when we are dealing with demand. So we will give you something like the price of the commodity in an equation form. That we want you to find for the X. That will be the price. But in demand, instead of the X, it will rather be P. I hope it's clear.
Yes, sir.
Hello?
Yes, sir.
Okay,
Yes,
let's
sir.
go back to our next topic is quadratic equation. You know what? Don't be confused. We will just apply these equations when we are dealing with topics like demand and supply, consumer behavior, production, and other stuff. You'll be applying those equations in them. So just understand them. So when we are applying it, you don't find yourself wanting. So the next equation is the quadratic equation. When we talk about quadratic equation, we are talking about an equation representing in the form of ax squared plus b squared, bx plus c is equal to 0. Where the a, b, and c are constants, and a is equal and or not equal to what? 0. And the quadratic equation is also called a second degree equation. While the first one that we did, the linear equation is what? The first degree equation, or an equation of degree 2. Since the highest power of the variable that occurs is the second, whereas the linear equation has only one root. a quadratic equation may have two different roots. So in solving for quadratic equation, we use two main formulas. You can use factorization or the quadratic formula. You can also use graphical formula to solve quadratic equation. So using the quadratic formula, we learned from the basic math that when an equation is given in a quadratic form, you can use this formula. That is minus b plus or minus square root of b squared minus 4ac all over 2a. So using the quadratic equation, assuming they give you an equation of x2 plus 3x minus 4 is equal to 0. So with this kind of equation, you can solve it using the quadratic formula, where the a is 1. Then this 3 is the b. Then the 4 is the c. So giving you this formula, you just matter of substituting it into the formula. So we know that x here has a coefficient of 1. And this 1 is representing the a in the formula. Then this 3 is representing the b in the formula. And the 4 is representing the c in the formula. So any question given to you in a quadratic form, you can use the formula to solve it by just identifying the variables representing each of the coordinates. So we know a to be 1 from this equation. You know b to be 3 from the equation, then 4 to be c. So when we substitute it, it gives us negative 3 plus or minus square root of 3 square minus 4 bracket open 1 minus 4 bracket close all over 3 minus 3 times 1. So because we have plus or minus, so when you add this minus 3 plus the whole of this, it gives you 1 coordinate. When you subtract minus 3 minus this, it gives you what? Another coordinate or another value. So therefore, you get two values. Let's go to the drawing board. They're right there. Let's go to the drawing board.
Sir,
Yeah.
please, then when you substitute the numbers, minus 3 plus root 3 square minus 4, the AC is supposed to be 1 multiplied by the minus 4, but you've done it 1 minus 4.
Let's go to the formula, the board. Relax. Let's go to the board and solve it there. So using the quadratic formula, solve x2 plus 3x minus 4 is equal to 0. So what's the quadratic formula? So you know that the x1 then x2 is equal to minus b plus or minus. Hope it's clear. Yeah?
Yes, sir.
Yes, sir. Yes, sir.
So minus b plus or minus square root of b square minus 4ac. And we know that x square plus 3x minus 4 is equal to 0. Let me remove this, not to confuse you. So the first variable the first variable has a coordinate of 1, that is the a. Then the second variable, 3x, is the b. It has a coordinate of what? The s. The second variable has the coefficient of 3. Then this 4, the negative 4 is the c. Therefore, we know the b to be 3. So it's negative 3 plus or minus. So first of all, let's use the plus. Root. Then the b is what? B is 3. So 3 raised to the power. So b is 3 raised to the power 2. Then we know a to be 1. You know a to be 1. Then c to be minus 4. All over 2a. Hope it's clear.
Yes, sir.
This 3 raised to the power 2. And this minus 4 into bracket a. The coordinate for a is 1. The coefficient of c is minus 4. All over 2 times 1. So this gives us what? Multiply them.
So, sir, we are going to get minus 3 plus root of 6 minus 32 all over 2.
Is that clear?
Come again. So it's going to be the minus 3 plus root of 3 to the power 2 will give you 3 times 3. No. Yes, 3 times 3, which should be 9. So it should be 9. Root of 9 minus, then you multiply positive 1 times negative 4 in the bracket there. When you multiply, you get negative 4. So then again, negative 4 times negative 4 will give you positive 4, 4, 16. 4, 4, 16, all over 2. Please, you understand?
Yeah.
So the bracket, the negative 4 into bracket 1, bracket close, then the other bracket minus 4, bracket close. You have to multiply 1 by negative 4, the two brackets first, board mass. So when you get an answer of negative 4, then you multiply the negative 4 by the negative 4, which will be positive. Then divided by 2 times bracket 1, which will give you 2. I think you have to apply board mass. When you apply board mass,
So negative 4 multiplied by negative 4.
it will give you positive 16.
16.
All over 2. 2.
So the final answer is what?
So the final answer will be 3 plus 3 plus 16, which will be 16 over 2, which will be 8. 8. Yes. So negative 3 plus positive 3 will be 0. So it will be left with 16 over 2.
X1 is 8 over 2.
Yeah,
8.
8 over 8. Yeah, 8.
8. Yeah.
16 divided by 2 will be 8. Over 2.
Therefore, x1 is equal to 8. Then how do we get the s2?
So we change the sign.
We use the minus.
Yeah.
So minus 3 gives us what?
6 minus 6.
Minus 3 is 6, yes.
So what's the answer
16. X2 is 5.
Yes.
X2 is 5. Hope it's clear.
Yes, sir.
No, sir.
No, sir.
Okay. They've given us the quadratic equation as minus b plus or minus raised to the power b square minus 4ac all over 2a. And they've given you this equation to solve using this formula. It's a matter of substituting the equation into the formula. And we know that whenever you see any equation in this form, the first value is the A1, is the A. The second one is the B. And the fourth one is the C. And we are dealing with only the coefficients So x here has a coefficient of 1. Therefore, if we are saying that this is the A part of the formula, therefore, the A is 1. With the second one is 3x. And we are saying that the second variable on the equation is the B. Therefore, 3x, the coefficient of B is 3. Then the C is negative. Ken.
Hello, sir.
Yeah, I'm listening.
Sir, please, the square root, we just took it off. I was thinking we should have find the square root of the first one, 16. Once we get the answer, then we divide it by 2. We ignored it.
3 square is what? And root of 9 is what?
The square root of
3 square is what?
Is 3.
That's right.
3 square is 9.
So root of 9 is what? 3.
Yes. Okay, sir. I get it. Thank you.
Sir.
James.
Please, so the x2, is it x square or s2? Because I'm getting confused. Is it x square?
It's s square. This is s square. This one is s square. So when you substitute them into the equation, first of all, we know that the equation is negative b plus or minus root of b square minus a4c all over 2a. Therefore, when you substitute these variables into the equation, the x1 is 8 and the x2 is 5. I'll give you more examples for you to try your hands on.
Sir.
Yeah, Salome.
So please, I don't understand how you got the x1 and the x2. Which formula are you using for the x1 and which formula are you using for the x2?
Okay. When we get the quadratic equation is saying that you are to add negative b to this, or you have to subtract the negative b to the whole of this. So when you get the negative b part and you add it to this, what you get is the x1. So when you subtract this negative b from this, and what you get is the s2. Is that clear? It's because of this formula. It's plus or minus the whole of this. So let's look at this part. We got 3. We are using the plus. So negative 3 plus the whole of this gives us the x1, which is the 8. And when it comes to this, it's minus 3 minus. We are not using the positive, we are not using the plus again, but instead the minus. So when you negative minus this gives us the s2, which is the 5.
Hello, sir.
Yeah, Ken.
Sir, please, I still have problem with the square root. Because is the square root affecting the whole of, for instance, with the first x1? Is it affecting 3 to the power 2?
It's only the b, the negative b.
B square, that is affecting it.
Yes.
Okay, sir. Thank you. Oh, oops. Sir, please, can you go back to the formula for us? Can you go back to the formula?
Have we seen it?
No, not yet. We are still seeing the board. Also, if to affect you, let's move on.
Before you go back, before you
Yes,
go
sir,
back,
please,
let me
let's
ask a
move on.
question, sir.
Yeah. Sir, it's fine.
So please, with the X1 and X2, I think the answers differ from the one in the slide. So is it a different thing or something?
Square root of
Please go
Yeah,
over the formula for us.
I'm coming. The quadrat, I'm coming. The quadratic, the square root affect the entire distance.
Yes, sir. That was what I was.
Yes, it affects not the b alone. It affects. I'm coming. Let me share the slide. Yes, it affects the whole
numerator.
Yes. Can you see the slide?
Yes, sir. We can see it now.
Yes, it affects the whole numerator.
So
yes, it affects the whole numerator. So first of all, the b minus b plus or minus the square root of this all over 2a. So this is the equation. S2 s squared plus 3x minus 4 is equal to 0. So when you get this kind of equation, we are saying that whenever you see somewhere.
Please, with the square root, is it that is a mistake or something? Because the square root is affecting just the b squared here. But there's a certain sign which is separating the b squared from the 4ac. So is it that the square root there is a mistake? That is, it's not covering the whole numerator or something? Because this is just covering the
whole numerator. It affects the whole numerator. It affects the whole numerator.
Then please, you have to correct your slides for us because it's a bit confusing.
No, the slides is okay. So I'll it's okay. I would rather put bracket here for it to make it simple for you.
Yes, sir. That will be good.
I'll put a bracket there to make it simple for you.
But sir, it doesn't mean what we have calculated. It means
so just apply the square root.
For that. Okay.
Yes. So the final answer is this: minus 4, then 1.
Okay. So after we do those interpolation within, then we square root first before we divide by 2.
Yes. So minus 3 plus or minus is the square root of 3 square minus 4 bracket 1 minus 4. It's multiplying.
Yes, sir.
So the final answer is.
Please, can you take your time for it? Because some of us are not getting it. So please, can you use the square root to solve it for us again? Because I'm getting confused here. I don't know if others are okay.
That's why I'm making sir go over, please. So you let me do so you understand, okay? Sir, please look at the 1 minus 4. The 1 minus 4, A and C are the formula, they are multiplying.
They are multiplying.
So do we have to multiply them before we subtract it from? No, we multiply before we multiply to the 4.
Yes, they are multiplying. It's 4 times 4 times C.
So the workings here, 1 minus 4 in the bracket. It means that we have to multiply, so it will be 4 alone.
Yes, 4 minus 4. So minus 4 times 4 gives you what? 16.
4. Yes.
16.
So I beg you, the 1 minus 4 there is confusing. Because it looks like you have to take it out
Yeah,
before
I'll
you
do the
multiply.
correction.
Yes,
I'll do
please.
the correction there. I'll do the correction there. So just get this clear. The formula is saying that x1 and x2 is equal to minus b plus or minus square root of a square minus 4ac all over 2a. And they've given you an equation in this form. In the equation like x squared plus 3x minus 4 is equal to 0. Whenever you see such equation, we are saying that the first variable with x squared gives you is what? The a aspect of the equation, the aspect of the formula. The second aspect gives you the b part of the formula. And the c aspect of this equation gives you the c part of the formula. So it's a matter of substituting it into the equation, then you simplify it. So when we substitute the b into the b of the formula, we get negative b plus or minus square root of 3 square minus 4 multiplying, because we know it's a is 1, and it's also multiplying the c. The c is minus 4. So 4 times 1, 4 times minus 4 gives you 16. And negative and square root of 3 is what? 9.
Hello, sir.
So,
sir, please, can you put a bracket between the -4 and the 1? That will make it easier. If you can adjust it with any, maybe if you can mark it. I don't know if it's possible. Yeah. Thank you, sir.
So the 4 is multiplying 1 and the minus 4. So minus 4 times minus 4 gives you what?
It will give you
Positive 16.
Yes. So root of 16 is what?
Root of 16 is 4.
The root of 9 is what?
3.
So 3.
So sir, please, does it mean when you are working, if you want to break it down, it means the -3 plus or minus root of 3 to the power 2, no? We should first of all break it in the bracket. So we know 3 to the power 2 is 9. We fix it there. Then we come to the -4. Positive 1 times -4 will be -4. So -4 times -4 will give us positive 16. Then we root the square root over the 9 and the 16. Then we take away 9 from the 16. Then we square root the remainder. Once we square it, then we divide it by, then we add, then we do -3 plus the answer we have square root divided by 2. Can we do it like that?
Yes, you can add it, then you do the square root. That's the best approach.
Okay.
Because when you're applying board mass,
right,
you need to finish the bracket before you can proceed to any other.
Yes, sir. Yes, sir.
Got mail.
So our next topic is simultaneous equation. So in economics, you also apply simultaneous equation in solving determining economic decisions. For instance, we can give you, at your level, we can give you equation of a demand equation, then supply equation. Or we can give you 2 equations and we want you to use simultaneous equation to find out the value for price and the quantity. So in price theory, we mostly applied what? Simultaneous equation to determine the single commodity market. For instance, when you have an equation like P is equal to 0, then like P squared is equal to 2, or P, then a second equation giving you P squared plus 3 is equal to 0. And they are asking you to find P. You can only find it by applying simultaneous equation. So simultaneous equation is very important in single commodity market decision making. So in simultaneous equation, you have several approaches in solving the simultaneous equation. You can either use elimination method, substitution method, or the graphical method. Is that okay with you? Or I'm going fast?
Yes, sir. It's fine.
Okay. So, assuming we have these two equations, and we are solving it using either elimination or substitution method. So with the elimination method, you can find the value of x and y in the pair of the simultaneous equation. First of all, you need to find an equivalent system in which the coefficient of the x terms in each equation are the same, except their signs. So for instance, you have y minus x squared plus 16, then 2x minus x plus 16. Let's go to the board. You have these two equations. Y minus 3x is equal to 16. 2y minus x is equal to 72. And we are using the elimination method. So with this equation, you first of all multiply the y So when you have this kind of equation, you need to adjust the equation so that one variable can be eliminated after solving. So first of all, we have y minus sy, 3x is equal to 16, 2y minus x is equal to what? 72.
Yes, sir.
So how can you eliminate one variable from the equation?
Then we'll multiply equation 1 by 2.
So for you to be able to eliminate one variable from the equation, we first of all adjust one equation so that we can get one variable to be the same. So when we multiply equation 1 by 2, so the equation 1 becomes what? It becomes 2y minus 6 is equal to 32. So as equation 3. Therefore, you need to subtract any of the equation 2 from the equation 3, so that we'll be able to eliminate one variable from it. Is that okay?
Yes, sir.
No, sir. Sir, please, can you go over it again?
We want to eliminate, we have two variables, y minus x, 3x is equal to 16. 2y minus x is equal to 72. We want to eliminate one variable from this equation. So we want to, first of all, you need to make one variables in both equations the same, so that when you subtract, you can eliminate it. So if you want to eliminate y from this, we need to multiply 2 by the whole of this. So when we multiply 2 by the whole of this, we get the equation 3. So therefore, subtracting equation 2 from equation 1, no, equation 3 from equation 2 from equation 3, we can eliminate this first variable. So equation 3 minus equation 2.
So equation 3 minus equation 1.
Still, you still come back to the formula. You still come back to the first equation.
Yes, sir. That's right.
When you subtract equation 1 from equation 2, you still come back to equation 1. So it's rather equation 3 from equation 2.
Sir, I think we should do equation 2 from 3. That would be easier.
Yes. So we are subtracting equation 3 minus equation 1, equation 2.
Yes, sir.
Yeah.
So 2y minus 2y is 0.
0.
Yes.
So minus x gives us what?
5x.
So
Sir, because the one with the minus x will become positive.
yes. So 5x is equal to 32 minus 72.
40.
It's negative 40 rather.
So it's positive 40 because the 32 also become negative. Because we are subtracting, we have to change all the signs within. So please, am I correct?
No.
So yes,
Yes.
because we are subtracting, we are changing the sign
Yeah,
in
we
front
are
of.
subtracting 3 from 2. So it will be 72 minus 32.
Uh-huh.
So it
No,
will be
sir, I think when we do that, the answer will become negative because 72 is bigger than 32.
no, it's not
So I
negative. We are
feel,
subtracting 3 from 2.
yes, so the 3 from the 2, look at the 3 is what?
So
2y minus
72
6x.
minus 32
72 minus 32 is what?
is 40.
It's
But here's
40.
the case that you're subtracting minus 72 from the 32.
So that's why I'm saying that it should rather be equation 2 from 3.
Yes.
It should be equation 2 from 3 so that
It's
when we
the
put the
same.
negative within,
It's the same. Okay. Let me.
Is equation 3 from equation 2. So when you are subtracting equation 3 from equation 2, it will be equation 2 minus equation 3. That is the English. When you say from,
you are right. I agree with you. Simply, she's right.
I want each and every one to understand it, to get it clear. You are subtracting
Equation 3 from equation 2.
Richard, how did you get the x to be 4, then y to be 40?
So please, I use the substitution method. I didn't use the elimination.
I just want us to try with the elimination, then we go to the substitution. So the equation 3.
It means that equation 2 will first of all write 2y minus x equals to 72, which is equation 2. Then now we bring equation 3 down.
2y minus x is equal to
2y minus x 72. This is equation 2. And then we bring equation 3 down. Yes. 2y minus 6
2y minus 6x
x equal to 32.
32.
Yes.
This equation.
So that now when we take equation 3 from 2, so that will be the negative 2y up to positive 2y will be 0. Then when we take minus x from positive 6y, because the 6 there is positive already, it's negative already, we just have to change it to minus. So 0 plus 5x, 5x is equal to, so 72 minus 32, that will be 40. So 1 positive answer. So I'll divide both sides by 5, then we get x equals 8. That's that. x is
X is equal to
8.
So therefore, you substitute this into equation 1.
Right. So when you why I need thousand, I need 1,000 and a big answer. 8, 60, 3 is 24. So y minus 24 is equal to 16. So y equals 16 plus 24. Hey, 16, yeah, 16 plus 24. And that's what I don't understand. So that will be 40.
Y is equal to 40.
40.
Is that okay?
Yes, sir.
Any question?
Yes, I said the y equals 40. 40 is big or is normal.
You're saying 40 is big.
I was thinking we'll get a lower number.
Lower number is in what?
Just like we've had x is 8, y is 40. I'm looking at how the graph will look like. So I understand it's okay.
So if you are to draw something with 40 and 8, would that be any big issue? Because when it comes to 8, instead of 8, you make it 10. Then the scale will be 10, 10, 10, 10. Then with the 8, with the y-axis, the scale will be, let's say, even if you make it 10, 10, 10, it will still be okay.
Yes, sir. Yes, please. Thank you.
I hope it's clear.
Yes, sir.
Yes, sir. Sir, it means with the equation has to be equation 2 minus equation 3. Now here, I've written equation 3 minus equation 2.
Like, you just want to, a way of eliminating one. So any way that can be easy for you is accepted. When you make it equation 2 minus 1, you're able to arrive at the solution accepted. Then you make it equation 1 from 2, and you arrive at a solution is accepted. But the way that will make it easier for you
Well noted, sir.
Let's go back to the slides. So we got the same answer over here, 8 and 40. Okay. Then the second method is substitution method. So with the same equations, it's a matter of making y the subject of the equation. Then you substitute it into the equation 2. So if you make y the subject of the equation, it becomes y it becomes y is equal to 3x plus 2. No, 3x plus 16. Therefore, we substitute okay, this is still equation 4 because we are basing on the other. With the same equation. So with the same equation, we are using the substitution method. So when it comes to the substitution method, it's a matter of making the first equation, y from the first equation, the subject. So if we make y the subject of the first equation, we get y is equal to 3x plus 16. Therefore, then we substitute this y into equation 2. Let's go to the board. So we are using substitution method. We have these equations. So first of all, we make y the subject of the first equation. Therefore, making y the subject, y is equal to 3x plus 16. Then put y is equal to 3x plus 16 into equation 2.
Got mail.
Plus 16.
Then you expand. So 6x plus
32.
32.
Yes. Minus x
is equal to
72.
72.
Group like terms.
Let me group like terms. 6x
6x minus x. 7 minus x is equal to 72 minus 32. So we have 5. 5x is equal to 40. X is 8.
So then you divide both 2 by 5. So
Yes.
5x over 5 is equal to 40 over 5. Therefore, x is what?
X is 8.
Then put x is equal to 8 into equation 1.
Then let's do it equation 2.
We did for equation 2. So we need to put it into equation 1.
All right.
So y minus 3 into bracket 8 is equal to 16. So y minus 3 times 8 is what?
24.
It's equal to 16. Therefore, y is equal to 16 plus 24. Any question? Any question?
Hello, sir.
Yeah, Eunice.
Please, can we try additional example so
I'll
that
give you additional example to practice.
okay, sir.
Okay, let's practice this one. Which of the method do you want us to use?
Thank you, sir. Oh, sir, please, anyone.
Substitution.
You should use the substitution.
Yes.
So how do we go about it? Eunice?
Sir,
Uh-huh.
please ask the question.
Yes. So how do we use the substitution? So first of all, you need to make one variable the subject of the equation. Then you substitute it into the equation 2.
Okay, sir.
So from equation 1, make y the subject. So 3x plus 4y is equal to 23.
The elimination would have been easier.
They want us to use, so let's use let's use both methods. So let's finish with the substitution, then we go to the elimination. So you can use any of the formulas to find the values for x and y. If you see the elimination will be easier for you, then you can apply the elimination method. If you see the substitution to be easier for you, then you apply the substitution method. So let's apply both methods. So let's make for y the subject. So 4y is equal to 23 minus 3x. Therefore, y is equal to 23 minus 3x all over 4. Hope it's clear. Huh?
Yes, sir.
Then you substitute y Then put y is equal to 23 minus 3x all over 4 into equation 2. Is equal to 10. So 5x minus 4 is multiplying 23. So 4 times 23 is what? 4 times 23.
92.
So 92 over 4 plus 12x over 4 is equal to 10. Then you group like terms. 5x minus 92 over 4. So 92 over 4 is what?
23.
It's what? 70.
23.
23.
23.
23.
And 4 over 12 is what?
3. 3x.
Therefore, 5x plus 3x is equal to 10 plus 23. It's what? Is it 2x or 3x?
8x
8x is
equals
equal to 33.
33.
So 8x, therefore x is equal to 33 over 8. Then put x is equal to 33 over 8 into which of the equations?
1. Equation 1. Equation 1.
1. Three into bracket 33 over 8 plus 4y is equal to 23. So 3 times 33 is what? Huh? 3 times
99.
99.
99 over 8
99.
is what?
Plus 4y.
Is equal to 23.
So 99 over 8 is what?
12.35.
Okay, so 3 point what?
12.35. 12.37, sorry.
12.37.
Yes.
Hope it's clear. Is this clear?
Got mail.
Because when you group items, are you okay to this part?
Yes, sir.
Or still you want us to make it a decimal figure? I just want you to like follow the steps. So 4y is equal to 23 minus 99 over 8. So he said it's what? 12 point. 12 point what?
12.4. 12.4.
4y is equal to 23 minus 12.4.
Yes, sir. We get 10.6.
Y is equal to 10.6
10.6.
over 4. Any question? Hope it's okay now.
Yes, sir.
Yes, sir.
So it's almost time. So the other,
Use the elimination method.
yes, use the elimination methods. Like when a question is being asked, it doesn't necessarily mean that you should apply both methods. Just use the one that you see to be a bit simpler for you to finish the solution fast. So how do you go about the elimination method? We have 3x plus 4y is equal to 23 as equation 1. 5x minus 4y minus 10 as equation 2. So first of all, you adjust the equations to make sure that you can eliminate one variable from it. So for you to get multiply equation 1 by 5 and multiply equation 2 by 3. Is that okay? Therefore, if you multiply equation 1 by 5, it gives you 15x plus 20y is equal to 5 times 23 is what?
115.
So as equation 3. Then 15x minus 20y is equal to 30. Subtract equation 4 from x, 4 from 3. One 115 minus 30.
$85.
So 40y, y is equal to 85 over 40. The answer is what?
17 over 8.
Seventeen over 8. Bismarck.
So, please, it's a substitution method.
This is the elimination method.
Elimination.
Yeah. So I learned this is more simpler than the first one.
Oh, okay. Thank you.
Then you put y is equal to 17 over 8 into any of the equation to get the x. You know what? Don't stress yourself. When you are dealing with the demand and supply, it's a bit simpler than. So, but I just want you to know how it's being calculated mathematically. So when we are applying it in the demand and supply concept, it will be a bit simpler.
Yeah.
Yeah.
Yeah. Let's look at the equation 4. The equation 4 is you are multiplying equation 2 by 3. So we
Yeah.
have 15
Yeah.
x.
Yes. And what?
What y? Because you are multiplying by 3.
Yes. Thank you.
Okay. Well,
Oh.
12y. Yeah, that's correct. Yeah, that's correct.
Therefore, 12 minus 20 is what? Minus 12 is 40. 32, right? So minus 15x minus 15x is 0. 20y minus 12y. So it becomes plus. So 32. 20y minus 12y is 32y. Is that okay? $85 divided by 32.
$2.6.
So in economics, when you read this side of, since because we deal with the nearest whole number. So with 2.6, it should rather be 2.7. Is that okay?
Yes, sir.
If it were to be in a normal mass, you can leave it as a fraction. But in economics, you can make it a decimal, but it should be the nearest whole number. Then you put 2.6 into equation what? 1 or any of the equation. So from the first one that we did, you can better still convert it to this decimal. Unlike normal mass, whereby you work out till you get the final answer where you can convert it to decimal. But in economics, so that way you can still convert it. But it should be in the whole number, nearest whole number. But at times you want it to finish with the various steps. Therefore, when you arrive at the final solution, the final answer, then you can convert it. So 3x is equal to 23. 4 times 2.7 is what?
10.8. 10.8.
10.8 minus 23. 23 minus 10.8.
12.2.
So 3. So x is equal to 12.2 divided by 3, which is what?
4.0. That's
4.70
4.1.
or 4.1.
Yeah,
4.1.
4.1.
So the one that we did, we can still convert it into decimal to solve it to make it easier for you. Any question? I hope you are done for the day. I have more examples for you to try your hands on. I hope you have a group studies, right?
Mail.
Yes, sir.
Yes, so in your various groups, share it among yourselves, then solve it. Prepare, because my questions is not that it not be all that simple, but it will come from all the sample questions that I've been giving you after all the slides. So when you check the slides, I have possible answer questions. My exams will come from there. So you need to try your hands on all the examples that I've been giving you. Just practice it. It will come from the slides. That's the reason why every topic I give you sample questions to try your hands on. Okay.
How many questions are we looking at? And how many are we answering?
We've not read there.
And are you also going to give us the formulas?
We've not read there. So when we are done with the quiz and other stuff, we know how the questions will be set. Or it won't be all that difficult. It won't be difficult at all. It will be as easier as class 1 questions.
Thank you, sir.
I will trick you small. My questions are based on critical thinking. I just want you to think small, so that when you become leaders, you can apply your knowledge in decision making.
Thank you, sir.
So the question will be, yeah.
Is that then in this case, is it possible the questions you are giving us, you also add the trick ones, the one you are going to trick us?
All the trick questions are part of the slides I've given you. For instance, if you check from the production possibility curve that we did, you saw that it's not just a simple question. It was a bit tricky. Or if you not checked from it, you've
Hello,
never seen
sir.
it.
Sir,
Yeah, okay.
please don't trick us. Sir, please don't trick us, please.
No, this is not tricky. But like, you check from the production possibility topic that we did. It was not
Right.
just it wasn't a straight question like, what is production possibility frontier? What is this? No, I will never ask such a question.
Okay.
You will never see question in my exams as what is this? What is that? You can never see that. I will never.
Oh, wow.
So
But there will be something like uh some case, then you use it to solve the question.
Sir,
I'll
is
give
there a case like a
I'll give
bigger?
you some scenario.
Okay.
I'll give you some scenario so for you to pick pick the definition from it. But you know, I won't give you like there will be nothing like what is this, what is that, what no, that one there. Mm. Well, like you check. Let me see if I can share that slide. No, but I gave you some notes. You saw the note on for week 1 and 2. For instance, the practical application 1. The following shows the production possibility for a plant that can manufacture iron or steel. Column AD shows a number of ions of each metal that can be produced for each alternative. So this is a practical question. This is a practical question. This is how I'm talking about. It's not like I'll give you what is production possibility curve. What is production? No, that one there is below your level. I hope I'm okay.
Yes, sir.
But now you are becoming a procurement expert. So you need to think critically.
Yes, sir.
So this is a practical question. They are all practical questions. They are all practical questions. So for yes, you try your hands on these questions because the exams, a question will come from these. One question will come from this part.
The only one.
And I think any question from this part will be a compulsory question. Oh, we've not reached there, so don't worry. We are now in week what? Week 6 or what?
Week
Yes, week 6.
Yes.
Week 5.
Week 5. No, we count. The Easter is part of the week, so.
7.
Okay. So our next topic will be on demand and supply. So I want each and every one.
Long lasts.
I want each and every one to, get some time and read on demand and supply. Because when we read that, it will be as fast as what? As fast as possible, because we are far behind time because of the Easter break. So read the demand and take any book. I've given you sample book on the LMS. Go there and read. Okay. Let's call it a day. Bye.
Okay. Thank you.
Yes. Thank you very much.
You're welcome.
You've got mail.